Alright, so we continue on. We talked about infinite limit. We have also a negative infinite limit. You can go off to negative infinity if it shoots off in the downward forever. That's called a limit that equals negative infinity. So you've got several different limits. You can look at limits just from the left or just from the right, and they can equal either infinity or minus infinity. It just depends on the problem. If you look at this one, as you're approaching a from the left, it comes in this way and it shoots off to infinity, so it equals infinity. If you look at this one, it approaches a from the right with that little plus sign, so that means as you come in this way, it shoots off to positive infinity, and that's what it's equal to. This one is a from the left, so it's coming in this way and it shoots off in the negative direction, so it's negative infinity. And this one is a from the right and it comes in this way and it's going off to negative infinity. So you can have all sorts of combinations with left and right-handed limits. If you have a left or right-handed limit that equals infinity or minus infinity, or even a limit itself that equals infinity or minus infinity, you have a vertical asymptote at that point A, and that vertical asymptote is called x equals A, the line x equals A. Alright. Example 7 talks about does the curve here have a vertical asymptote? Well, there's a potential vertical asymptote whenever the denominator equals 0. So here, if x equals 3, it's not defined. So if you look at this guy, if you come at it from the left, it shoots off to infinity. If you come at it from the right, it shoots to infinity, and from the left it goes to minus infinity. But if you look at it numerically, if you get closer and closer to 3 from the right, this x minus 3 is really like 3.1 minus 3 is 0.1, 3.01 minus 3 is 0.01, and all these numbers are small, but they're positive small. And now the top is approaching 6, because this gets closer and closer to 3, and 3 times 2 is 6. Now if the top is a fixed number, no matter what it is, if the bottom gets infinitely small, then that goes off to one of the infinities, either positive or negative. Now how do you know which one? Well, this is approaching a positive 6, and that's these are all positive small numbers, so positive over positive is a positive infinity. Now if you were to come at it from the left, you're looking at 2.9 minus 3, which is negative 0.1, and 2.99 minus 3, which is negative 0.01. But again, the top still approaches 6, because whether you're coming at 3 from the left or the right, you still approach the same number of 6. So the top is a fixed number. The bottom is getting infinitely smaller, negative. So that goes off to negative infinity. Alright. So if you look at the two different examples, example 6, this one goes off to infinity on both sides. So this has an infinite limit, and the infinite limit exists. Alright. Now this one, if you look at it from the left and the right, it's going off in both directions, opposite directions. They do not, the left and right hand limit do not equal each other. So you can say that the limit does not exist. Now, this limit does not exist either, but it does have an infinite limit. Remember, the infinite limit is not a limit that exists, but it's just a definition. All right. So here they give you a problem where they say f of x equals tangent x. Tangent x is sine over cosine. So now where is your denominator equal to 0? Well, wherever cosine equals 0, and that's at pi over 2 and 3 pi over 2, and every pi units further in either direction. And so if you look at just pi over 2, if you come at it from the right, you get negative infinity. Come at it from the left, you get positive infinity. So it does not have an infinite limit, per se, but one-sided wise it does. One-sided from the left it's infinity, and from the right it's negative infinity. And also you can say that it has an asymptote at x equals pi over 2.